Okay, so we're going to find f of x given that the second derivative is this, the first derivative when x is 1 is 2, and f when x is 2 is 3. So the first thing we want to do is integrate. So the integral of the second derivative is equal to the first derivative, and the integral of the first derivative is going to give us f. So the integral of the second derivative is this. I'm going to rewrite this as x to the negative 2. So when we integrate x to the 2, we get x to the 3 over 3. And when we integrate x to the negative 2, we get x to the negative 1 over negative 1. And then we have our constant of integration. So let me rewrite this a little bit. So we have x cubed. So keep in mind this is the first derivative. So we have x cubed over 3 minus 1 over x plus our constant of integration. But we're told the first derivative when x is 1 is 2. So f prime of 1 is, well, we plug in 1, we get 1 cubed over 3 minus 1 over 1 plus c, and we're told that this result is equal to 2. So now we want to find out what c is. So we have 1/3 minus 1 plus c is equal to 2. 1 we can think of as 3 over 3. 1 minus 3 is minus 2/3. So we have minus 2/3 plus c equals 2. And when I add 2/3 to both sides, we find that c is 2 2/3, or 6 plus 2 gives us 8/3. So the first derivative is x cubed over 3 minus 1 over x plus our constant, but our constant is 8/3. Now, if I integrate our first derivative, we're going to get our function f. So let me erase this. So the integral of the first derivative is equal to our function, and, well, it's going to equal our function, but let me integrate our first derivative. X cubed over 3 minus 1 over x plus 8/3. So we're integrating this with respect to x. Again, that's what this is f. So f of x is going to equal x to the 4, and when I divide by 4 and multiply by the 3, we're going to get x to the 4 over 12. The derivative of the natural log of x is 1 over x. So the integral of 1 over x is the natural log of x. We have minus the natural log of x. Integrating 8/3, we get 8/3 times x, because the derivative of this is 8/3. And then we have another constant. Now I'm going to put c1, because it's not this, I'm not going to use c again. Again, this is a technicality, it's a different constant. So I'm going to write c1. But we know that f of 2 is equal to 3. So using that information, f of 2 is 2 to the 4th over 12 minus the natural log of 2 plus 8 over 3 times 2 plus our constant, and we're told that this is equal to 3. And now we just solve this for c1. So what do we get here? 2 times 2 is 4, times 8. This is 16 over 12. Let me do this on the side. 16 over 12 reduces to 4 goes into there 4, it's 4/3. So 16 over 12 reduces to 4/3 minus the natural log of 2 plus 16 over 3 plus c1 is equal to 3. So when I add these, 16 plus 4 gives us 20/3 So we get 20 over 3 minus the natural log of 2. If I move this to the other side, we find C1 is 3 minus 20 thirds plus the natural log of 2 when I move that over. 3 we can think of as 9 over 3. 9 over 3 is 3. 9 minus 20 is minus 11. So we get the natural log of 2 minus 11 over 3 is C1. So now we go back and plug that in here. And I'm just going to erase all of this. So we see that our function f is x to the 4th over 12 minus the natural log of x plus 8/3 x plus C1, but C1 is the natural log of 2 minus 11/3. So this is our constant here. Now you could use the properties of logs and write these two as a single log, but I'm not going to bother with that. I'm just going to leave it like this. So this is our function given that what the second derivative was along with those initial conditions.